This is Mr. Precella and it's Math 1324 class today. And we're going to be discussing compound interest today. The last time we discussed simple interest, I equals PRT. And during the lecture I mentioned that with simple interest, the interest is calculated only once, period. And I asked, well, suppose interest is calculated more periodically. Instead of the interest just being calculated one time during the time period, what if maybe it's calculated every month and added to the account? That's referred to as compound interest. If you see a statement about a savings account where interest is compounded daily, that means every day the bank calculates interest on your money and adds it to your account so that the next day you have a little bit more principal, therefore you'll get a little bit more interest. This way the principal is growing as often as they're calculating interest. If the interest were calculated monthly, let's say, then every month the bank at the end of the month calculates the amount of interest, adds it to the account so that the next month you have more in there and you're going to earn even more interest. That's what we mean by compound interest. We're going to look at a compound amount formula. And that formula looks like this. A equals P times 1 plus I, that's a lowercase I, to the n power. It's a lowercase I right here. Made my dot too big. Okay. Now on this, the P and the A are the same as with simple interest. The P is the present value. The A is the future value. On a timeline, it would look like this. Here's the amount of money invested today. After some period of time, here's the future value. The new variables, by new I mean they weren't included in the I equals PRT simple interest formulas, are this lowercase I. That's why when we were doing simple interest, I kept talking about capital I. Here's an example where I was working out a problem with simple interest. That's written with a capital I. The lowercase I, what that stands for is the interest rate per period. To calculate lowercase I, you're normally going to divide. You take the stated rate, and the stated rate is always an annual rate, that nominal rate, and you're going to divide it by the number of periods per year. Number of periods per year. Now, T and the simple interest was the time in years. N is the total number of compounding periods. Suppose interest is calculated monthly for 10 years. Well, how many times are they calculating that interest? Well, that would be 10 times 12. In general, if you want a formula for N, it'll be the number of years times that same bottom number you used right here, the number of periods per year. And the period, it depends on, are they talking about daily, or is it being compounded monthly, or so forth. And you'll see that as we do the examples. Now, something to keep in mind is this formula does not give you the actual amount of interest. If you need to know the actual amount of compound interest, you're going to have to subtract. What the formula does is give you that future value. To get the amount of interest, you would have to subtract future value minus present value. Let's do one of these problems. Let's do problem number 1. It says, suppose that $10,000 is invested at 7% interest. Find the amount of money in the account after 9 years if the interest is compounded annually. Okay, the interest is compounded annually. Well, it has that key phrase compounded, so it's not a simple interest problem. So I'm going to be using A equals P times 1 plus I to the n. That $10,000, that's the amount of money that's invested today. P is $10,000. If you want a little timeline, it'd look like this. We're investing $10,000 today. I is the interest rate per period. So here's the first time I'm actually doing this. I'm going to calculate I. Let me see. Is there room to show it right here? Lowercase I. You go stated rate, 7%, over the number of periods per year. Well, that's easy because it's compounded annually. So how many years are there in a year? Well, 1. If it had said monthly, that bottom number would have been a 12. If it had said daily, the bottom number would have been 365 if that's how many days we're using, or 360. So I is 0.07, and N is the total number of compounding periods. N is the number of years the money's invested times the number of periods per year. Well, again, this one's the first one, so it's sort of easy. It's invested for 9 years. How many annual periods are there in 9 years? Well, there's 1 annual period per year, so N is 9. Yeah, this is the first one, so it's rigged. Not be too hard for you. So now I'm going to plug into A equals P. You know what? It just dawned on me. I'm losing a 0 here, or I'm missing a 0. I wrote 1,000, whereas in reality it's 10,000, isn't it? Times 1 plus I to the nth. Well, you're going to start seeing me do something. For this 1 plus I, if there's something that's just so easy to calculate, I'll generally just calculate it in my head rather than punching that in like that. 1 plus 0.07, all of y'all can figure that out as 1.07. $1 plus 7 cents is $1.07. And so that's what I'm going to punch in right there. 1,000 times 1.07 raised to the 9th. Punching this in, let's see. Clear all of that. I said 1,000. I meant 10,000 times 1.07 raised to the 9th. $18,387. $384. We're told round to the nearest cent. So what would we call that? 59 cents? That's the amount of money that's in the account after 9 years. Realize that's not the amount of interest. If you wanted the amount of interest, which this problem isn't asking for, you wanted the amount of interest, you would have to subtract the original 10,000. Okay? Here it is, worked out. Okay? Any questions? Also the following this is the compound amount formula that we're working with. Well, let's do number 2. Find the compound amount for the following deposit. Okay, this is going to be a good one to practice finding lowercase I and lowercase n with. Okay, find the compound amount. It's just telling you, okay, use this formula. A equals P times 1 plus I to the n. So you're finding the future value, A, the amount. P is 11,000, but let's practice finding lowercase I and lowercase n. Lowercase I. Lowercase I is the stated rate per period. In this particular problem, the period is quarters. So you're going to go stated rate. Lowercase I is the interest rate per period, not the stated rate. The interest rate per period. So you're going to go stated rate divided by the number of periods per year. To get n, you're going to go number of years times number of periods. And the periods that we're dealing with are quarters. So to get I, that's 0.07. That's the stated rate. Now, how many quarters are there in a year? How many quarters are there in a year? 4? If I divide 0.07 divided by 4, if that fraction terminates, and it does, 0.0175, I'll use that. I think that'll make it a little easier. If it didn't terminate, then I'd have to leave it and work with the 0.074. So 7% compounded quarterly is like 1.75% each quarter. If you add 1.75% at 4 times, you're going to get 7%. That's what lowercase I is. Lowercase n is the total number of periods. To get lowercase n, you multiply number of years times number of periods per year. It's going to be that bottom number right there. So number of years, it's 5 years times, there are 4 quarters in a year. So altogether in 5 years, how many quarters are there? Well, there are 20. So to find A, you're going to punch in 11,000 times 1 plus I to the 20th power. Now I'm going to go ahead and calculate the 1 plus I in my head. So here's what I'm actually going to punch in. 11,000 times 1.0175 to the 20th power. Move this up a little. 11,000 times 1.0175 raised to the 20th. That's going to give us $15,562.56. So that's the amount of money that's in the account after 5 years. That's called the compound amount. Okay. calculator so you can see the whole problem. $15,562.56. That's problem 2. Well, the number's not significant. Problem number 3. A newborn child receives $4,000, a $4,000 gift toward a college education from her grandparents. How much will the $4,000 be worth in 17 years if money is invested at 5.4% compounded quarterly? Well, to calculate I, you would divide 0.054 over, how many quarters are there in a year? 4. Let me punch that in. 0.0135. So that's lowercase I. To calculate N, how many quarters are there in 17 years? You go years times number of quarters per year. So there are 68 quarters in 17 years. And that $4,000, that's the amount being invested today. You want to calculate how much will be in that account after the 17 years. So this is A equals P times 1 plus I to the N. P is 4,000. The 1 plus I, I'm going to go ahead and do that in my head. 1 plus 0.0135 is 1.0135 to the N power. N is 68. I know sometimes I start going quickly on these videos, and if I'm going too fast, it wouldn't be a bad idea for you to pause the video and work it out with me, okay? So let's see. Nice grandparents. Okay, let me clear this. Okay, 4,000 times 1.0135 raised to the 68th power. Okay, so $9,955 and 78 cents. Is that how we're told to round it? We're rounding to dollars and cents. So the answer right there, 99.55.78. So in 10 years' time, that child can use that money to buy my math lab access. I'm sort of joking, you know, but the way things keep going up, price of higher ed, so $9,955.78. Number 4. The following certificate of deposit was released from a particular bank. Find the compound amount and the amount of interest. Well, with a certificate of deposit, you give the money to the bank and they keep it for a set number of years. In this case, it was a 3-year CD. The number of years they keep it is decided right at the beginning. How long is the CD going to be? And after the 3 years, you get the $3,000 plus all the interest. If you have to get that money out early, there's usually a substantial penalty. You're not going to get a CD if you're thinking you're going to be needing that money soon. So to do this, well, I'll just move it on up here. $3,000 is being deposited into an account today. The money is compounded semi-annually for 3 years. So semi-annual means what? Twice a year? Every 6 months? So P is 3,000. I'm using that formula. A equals P times 1 plus I to the n. I is the interest rate per period. The stated rate is always an annual rate. 1.01%. How would I write that as a decimal? It would be 0.0101. Now, how many semi-annual periods are there in a year? Well, there's 2. So 0.0101 divided by 2, that would be a 0.00505. You might have heard me punching in my calculator. So so you go stated rate divided by the number of semi-annual periods in a year. N is the total number of periods. Well, how many semi-annual periods are there in 3 years? 3 years, 2 per year, N is 6. Now, plugging in, A equals P times 1 plus I, I'll just add those to the nth power. Now, if this I doesn't terminate, then you're going to have to just leave it as 0.0101 over 2 and work with it like that. Don't round off anything until the very final answer. Bringing my calculator back. 3,000 times, that's better, 1.00505 raised to the 6th power. That's $3,092. And if we're going to round to the nearest cent, what would y'all call that? 6 cents? I'll agree with 6 cents. So that's the first answer. That's the compound amount. That's the amount of money they give you after the 3 years. But that's not the interest earned. To get the interest, you subtract the 3,000. So $92.06 is the amount of interest that's earned. Well, I think that's enough for now. I'm going to take a short break, and I'll pick up and do more of this compound interest, compound amount problems, okay? So I'm taking a break. I'll pick up later.